Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. As you can see, I have made a simple little display where there's a virtual environment, a sort of retro-looking dungeon, I guess, and we've got some controls down here which allows us to move through it, and it is quite consistent. If there's a wall in a particular place in one frame, it'll be there in the next. So it's an environment that sort of does what we want an environment to do. It's sort of things stay where they are, and we have a simple set of controls here allowing me to turn left, turn right, and go forward, and then we have a little message saying which direction I'm facing in. In a real game, you would almost certainly have more controls than this. You'd probably have a control allowing you to step left without changing your facing and step right without changing your facing. You'd probably have a control allowing you to step backwards without changing your facing, and the message about your direction would probably be a graphic, like perhaps it would be a compass or something like that. But I've done the sort of minimum to get it working so that I can show you how it works. So before I get into the program, I should say that this is a little more complicated than most of the things that I've done on this channel. So I'm not going to get through it in one video. It's going to take at least two and perhaps three videos to explain how this works in sufficient detail. But with that caveat, you've seen what it looks like. Let's have a look at the code. So the structure of the program is quite simple. There are only 4 pages. Initialize, where we set up the variables. Generate, where we set up the details of the environment. Position, where we set up where the character starts. And then display, which is choosing what pictures to display. And also this has the controls that allow you to turn and so on. And when you turn and go forward, it just moves from display to display. In fact, most of the time that you're in the program, you'll only be on this display page. Now, I said pictures and not picture because although this looks like a single graphic, it's actually several graphics. You can sort of see that when I choose things. So what I've chosen there is a separate picture to that, and then the bit that I picked there is a different one again, and so on. But of course, it's displayed so that it looks like a single picture. But more of that later. Let's get back to the code, and let's start with initialize. So the first thing that I did was define how big the environment is going to be. I picked a very small size to start with. The X and Y dimensions are each 10. And in fact, really effectively, it's 8 by 8 because the outer wall, the outer edge, is all solid blocks. And the reason the outer edge is solid blocks is so that you can't move out of the bits that have been defined into bits that haven't been defined. So we set X and Y. We have a note. These are the variables which will hold which pictures we're going to display, and we'll look at that later. We have to have a direction for the character because, of course, the dungeon looks different facing in different directions. So we need to know which direction they're facing in. I've decided that 1 is north, 2 is west, 3 is south, and 4 is east, fairly arbitrarily. And I've set that, I've decided to use the variable $D, and I've set it to 1 to start with. It could be any other direction. It could be determined randomly. It doesn't really matter. So we have two arrays, two-dimensional arrays that keep the state of the state of the environment. So we have M, which is once it's defined, it doesn't change. Once it's defined in generate, and after that, it won't change. So in a real game, you might have some possibilities where it does change. So, for example, you might have the ability to look for secret doors, and then if you find a secret door, a block might change from apparently being wall to having a door in it, so that you remember and sort of walk through it, for example. But in this sort of demo, it will never change, and it has the simplest possible range of possibilities. There's only two. One is a wall, a block of wall, and 0 is open space that you can move through. So M will not change, and we have another array, E, which does change. In fact, it changes every move, because E is keeping track of the environment immediately in front of and to the side of the character. And of course, that's going to change as you move, and also it changes as you turn, because it stores things in terms of what's forward of the character and what's left and right of the character. And as you turn, which direction is your left and which direction is your right, and which direction is forward of you, will change. So if you're facing north, north is forward of you, west is to your left, and east is to your right. And let's say you turn 90 degrees and you're facing east. Well, now north is to your left, and south is to your right, and east is to the forward of you. So why do we need to do this? Well, because of course this is a first-person display. It's a display of what the character would be expected to see at that particular position, facing in that particular direction. So we need to know what's near them at any given stage. So they're both two-dimensional arrays, E and M, and in Twine, when we're setting up two-dimensional arrays, we first define it as an array. So we say set $E equals square bracket n square bracket. That creates a one-dimensional array, and then we go through, and for every slot we need, we turn that slot into its own array. So in the case of E, we go from 1 to 5. We have a for loop that goes from 1 to 5, and it sets E, whatever the number is of the loop, to be an array. So E1 becomes an array, E2, etc. And we do the same thing with M. Now, you might notice that this for loop goes from -1 to x plus 1. And you'd probably expect it to go from 1 to x, because you'd probably expect, well, we need to be able to refer to position 1, 3, so we need M1 to be an array. But why do we need 0 and -1 to be arrays? Well, you might think, well, perhaps he's doing what computer programmers sometimes do, and counting from 0, making 0 the origin point. Okay, but that doesn't. But that would explain 0, but it doesn't explain -1, and it doesn't explain x plus 1. Well, the reason for that is because of the way that E works. In E, we need up to 2 squares forward of the player, and up to 2 squares to the right of the player, and up to 2 squares to the left of the player. And if the player is right near the edge of the environment, depending on which direction they're facing, 2 squares forward or right or left of them can be outside of the environment. And so we need to refer to squares that aren't in the range 1 to x or 1 to y. And because of that, so that we don't get an error, so that it doesn't say, oh, that's not defined, we start from -1, and we go to x plus 1. And then we have several temporary variables listed there. And as I say, we have a few variables that are used to store which pictures we're going to display at any given point. And they stand for center, left, right, center, left, center, center, and center, right. The reason we have center and center, left, center, center, and center, right is because sometimes the center bit of the picture will be one PNG file, and sometimes it will be 3. But again, that's something we'll probably deal with in a future video. So having set up all the variables, or listed all the variables, we then have to generate the environment. Now, there are a lot of there are a lot of algorithms for generating mazes or generating caverns, generating environments. I have found the ones that I tried to be far too slow. Twine either takes forever or actually it generates an error because it requires too many. Well, if you use include, it generates an error because that uses too many. It keeps track of all the includes that it's using, and if you have too many, it assumes that you're stuck in a permanent loop, and it generates an error and stops the program. You can get out of that by using go-tos instead of includes, but that doesn't solve the problem that they just take way too long. So yeah, most of them took too long. Some of them looked like they wouldn't have very satisfactory results. So I actually don't recommend using any algorithms that you might find on the web, or at least any that I've been able to find. What I am actually going to recommend is that you generate the environment as you go. So you look at the environment, and if you need to know about a square that you haven't defined yet, then you define it at that point rather than setting up the whole environment at the beginning. But I'm not doing either of those things in this case. I'm just doing a very simple method, which I definitely don't recommend. It's not a good method. It's just a quick method to allow me to demonstrate this. So we have a loop that goes from -1 to x plus 1. And we have another loop that goes from -1 to y plus 1. And we call those two loops x1 and y1 so that it's easier to keep track of the fact that they're referring to the x and y coordinates. And then we have this. If x1 is less than 2 or x1 is greater than x... If x1 is greater than 2... Oh, sorry. If x1 is less than 2 or x1... Sorry, that was silly. Okay. If x1 is less than 2 or x1 is greater than x minus 1 or y1 is less than 2 or y1 is greater than y minus 1, then we do this. Otherwise, we do this. So what is the significance of x being less than 2, x1 being less than 2 or greater than x minus 1, and y1 being less than 2 or y1 being greater than y minus 1? Well, these represent the squares that are on the very outer edge, actually the very outer sort of edges of the environment. Either they're either 1, well, in this particular case where we've set x and y to be 10, it'll be either 1 or 10 or less than 1 or greater than 10, and then the same is true of y1. So it's the edges of the environment, and then it's the extra squares that we sometimes have to look at for the purposes of setting up the E array. So, and I've made a little note here that says outer wall, which is a shorter way of saying what I just said. If that is the case, then we set m x1, y1 to be equal to 1, which is meaning it's a solid block. And then if that's not the case, so it's any other square, we set it to be random. It's either open or a wall. Now, I do not recommend that. That is a bad way of setting up an environment. It will mean that the player is cut off from most of the environment, probably, but it's good enough. It's good enough to demonstrate what I'm trying to do. So generate is actually fairly quick. In the final version, it'll be a lot longer because we'll be, using a bit more sensible a mechanism, and that means more code basically. Position is actually very quick. All we do is we choose x2 and y2. Well, that's going to be the player's coordinates, and it's a random number between 2 and x minus 1 in both for x2, and then between 2 and y minus 1 for y2. It's 2 and x minus 1 rather than 1 and x, and 2 and y minus 1 rather than 1 and y, because we know that the outer wall is a wall. And because we don't, if it is a wall, we re-roll anyway. So there'd be no point putting those options in. Because we see here, if m x2 y2 equals 1, then include position. Essentially go to the top of the page and sort of re-roll. And if that's not the case, and because every slot in M is going to be either 1 or 0, that means it will be open space, then we go to display. So it's between 2 and x minus 1 because 1 and x, if x2 or y2 equals 1 or x, that's just going to be a wall anyway. And if it's a wall, we're going to re-roll. So there would be no point having the possibility of generating those numbers. We've already set direction. We did that at the beginning. We just arbitrarily set it to be north. And then we go to display. Now, I won't go through this in detail because at this point things get a bit visual, and it's going to be easier to explain why we make the choices that we make while looking at the graphics, and that's probably a subject. It's a long enough subject that I'm probably going to do it as its own video. But I will tell you broadly what we do. Broadly, what we do is we fill in the E array. In other words, we say, well, what's ahead of the player, what's to the left of the player, what's to the right of the player, what's the player's immediate environment that they can possibly see to the left and the right. And once we've done that, and of course, it varies very much based on direction because we're looking for slots. The slots in E are based on what is forward of the player and what is left of the player and what is right of the player, which changes, and what that means changes depending on where they're facing. And once we've set up E, then what we see is, of course, dependent on what's immediately to the left and right of us. So we have a set of building block graphics, and we pick the one that fits the state of E. So, for example, we might say, is there a block immediately to our left? Yes, there is. Well, if that's the case, then there's a graphic for a block immediately to the left, and that's the thing that we'll put in the left side of the picture. And then, if that's not the case, is there one left and forward? Well, if that's the case, then that will make another picture that would look a different way, and we have a picture for that. I will go through in the next video. I'll sort of go through the details of that and make it a bit more concrete by showing you visual examples. But essentially, we do that for the left, the centre, and the right, and then we just display the relevant images that we've chosen. The only other thing I will go through is the buttons. I'll go through them completely because they're fairly simple and they only use commands that we've already used. You might have noticed we've got this div, which is sort of a paragraph. A line equals center, so that the picture is the picture and the buttons, etc., are all in the middle of the screen, rather than to one side. And then we've got this ID equals quote WHOLE end quote. And if you've been following this series, you'll know that we only really do div IDs. We've only used them when we're going to use the replace command. And in fact, that's why we're using it this time. We're using the replace command to minimize flickering when we move, because we're going to be moving from one picture, one or set of pictures to the next quite quickly, and we want to minimize the amount of flicker that we get. And the replace command is our way of doing that. So, with that in mind, let's have a look at these buttons. Now the left and right, the turn left and turn right buttons work exactly the same, so I'll only go through one of them in detail. So we have an array, and within a cell of the array, within a TD and a /TD, we have this code. This looks a bit weird, but all this is saying, when you have a button, first you have to have the text, and if the text is going to have a space, you need to put quotes like that, and then you have where the button takes you, so the link. And again, if the link involves spaces, you have to enclose it in quotes so that it knows what's happening. So what are we seeing up here? Well, all this is a button where the text is just that. It's just that less than symbol used as a crude sort of arrow, I suppose. And there's no link. So it's a button that just, it doesn't take you anywhere. It just does whatever's in here. And so what is in here is we set D++, which means we increase the value of the variable which is telling us what direction that we're in. And because the directions go anti-clockwise, 1 is north, 2 is west, 3 is south, 4 is east, well then turn the left button, the turn left 90 degrees button, is the one that increases D. It would be probably more instinctive for most people to have it going clockwise, but you know, anyway, I went with anti-clockwise. I don't remember exactly why. So we set D++, and because the numbers only go from 1 to 4, if D is now equal to 5, then we set it to 1. It goes back around to 1. And then we have this replace command. We replace quote hashtag whole quote, and we include display. So we're replacing this page from the ID whole, but because the ID whole is up the top, we're replacing the whole thing. But because we're using replace, it hopefully won't flicker so much as if we'd actually treated it as a movement to a different page. It's a sort of way of, I guess, tricking the program. And what we replace that section of the page, which is actually the whole page, what we replace it with is we include display, which is of course the page that we're on. So we're replacing the whole page with the whole page, but it's treating it as a partial replacement and therefore as not needing to have that transitional flicker. Note that I've got display in quotes, whereas normally it would be like that. So that is the button to turn to the left. The button to turn to the right is exactly the same, except that D is now reduced by 1, and if D is 0, it becomes 4. So it wraps around a different way, and then we have the replace and the include, which is exactly the same. And finally, I'll have a look at the button that is going forward. So this button is within an if. It doesn't always appear, whereas you always have the option to turn right and turn left. You don't always have the option to go forward because there might be a wall in front of you. And we determine that by looking at this particular slot in the E array. If E31 is equal to 0, well, E31 happens to be the square that's directly in front of the player character. Again, we'll look at that in a future video. So if that square is clear, is equal to 0, then we can move forward. And then we have, again, this slightly confusing looking code, but all it's saying is it's a button where this character is the text, and that has no link. And then it's looking at what happens, what does it mean to move forward? Well, what it means in terms of x2 and y2 depends on where you're facing. So if D is equal to 1, then y2 is increased. If D is equal to 2, which is facing east, then x2 is decreased, and so on and so on. We increase or reduce x2 or y2 by 1, depending on which direction the player is facing in. And then we have the exact same replace, include, / replace as we had before. So that is broadly how it works, but the devil's in the details, and so we probably need to spend at least one video looking at the details of how do we decide, how do we make the art, and how do we decide sort of what to call the different possible pictures, and how do we decide which picture to choose. And that will be the subject of my next video. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.